Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on IPv6. Let's start our part 4.
Now let's look into the IPv6 routing. Okay, so here we are going to look into the RIPng, OSPF v3, the version IPv4 is version 2. Then we are going to look into the integrated ISIS IPv6 and BGP 4 Plus for IPv6. Now first let's look into the RIPng, okay, or RIP next generation. Now they are using UDP port 521. They do allow you to use the destination with 128-bit that will be on IPv6 128-bit. And RIPng uses the link local address as the next hop, which is the FE80. Okay, so this is the one, all right, as the source address, and it's used as a update packet. RIPng periodically send routing information using FF02. As you can see that this is a multicast. Okay, that we explained earlier on, ::9. And RIPng packet consists of a header and multiple routing entry. Alright, so I'm going to show you a very short demonstration on the RIPng now. Alright, so here I have modified my lab slightly a little bit. So between R1 and R3, I'm using 2001-12 prefix, and between 1 and 2 I'm using 2001-112 prefix. Now firstly, on R1, let me show you my IPv6 address. Okay, so this is my address, and make sure that I can do a ping before we configure the layer 3 protocol. Okay, so let me try to ping to R3. Okay, so it's working, and I'm going to ping to R2. Sorry. Alright, so that is working as well. Now, for us to configure the RIPng is pretty simple. So let me start with R2. Alright, so firstly, just do RIPng. Now you can see that there's a 1 here, there's a process ID, that's number 1. Okay, so you need to go to the interface and you just do a RIPng process ID 1 enable. That's all you require. So once you've done this, you just want to confirm if your RIP has been enabled. So you can just do a display RIPng 1 interface. Okay, right now I should have no neighbor, right, because I have not enabled on the R1 yet. So now let me go to R1, RIPng interface gate 000, enable, and I go to the interface gig 001, enable. Okay, now I should actually have my neighbor there. So when I do a display RIPng1 interface, okay, so you can see that that's my interface, the interfaces here, as well as the neighbor. So between R1 and R2 I still can't see it, so just wait for a while because it would take some time. Now I have a Wireshark that's running between R1 and R3, so I go to R3 now and enable the RIPng, go to the interface and enable on the interface. That's all you require. Okay, and my interface is running. How about my neighbor? Yep, you can see that my neighbor is discovered. Now I would like to see my routing table. If my RIPng is working, I should be able to ping to R2. So let me do a display IPv6 routing table protocol RIPng. There you have it. So there's 2001:112::. Alright, and you can see that the protocol here is called RIPng. Okay, that is our prefix length of 64 with a preference of 100, similar to IPv4. So when I do a ping IPv6 2001:112::2, I should get a reply, and when I do a trace, Okay, IPv6 2001:112:2. You can see that it going through to HALP. Now, if you still remember on the theory, I did mention that we have the RIP-ng. Now you can see that on the RIP-ng here, we are using the UDP. Okay, firstly, and that is the UDP 521. Okay, that's the transport they are using on the RIP. And inside the RIP, the prefix that we have is actually carry the 128-bit prefix. And you also notice that the RIP-ng is using multicast. As you can see, that is an FF02::9, as I mentioned earlier on. Alright, so it's very easy for you to configure the RIP-ng, and the concept of the RIP-ng and the normal RIP IPv4 basically more or less the same. Okay, now let's look into the OSPF version 3. Now there are two versions on OSPF, version 3 for IPv6 and version 2 for IPv4. Now they do have some differences between V2 and V3, but they do have some similarity between them as well. Now firstly, they are similar in the sense that they do support the broadcast type, MBMA, point-to-point, and point-to-multipoint. And the interface state machine and neighbor state machine are the same. So for instance, we have a down state, then we have an init state, we have the two-way state, we have the xstart state, we have the exchange state, we have the loading state, and we have the full state. So this state that is available in IPv2, OSPF v2, is also available on OSPF v3. Now the link state database, the way on v2 and v3 is the same. Alright, then the flooding and the aging time is the same. We do have different packet over here. Altogether we do have exactly 5 type of packet, which is hello packet, database descriptor, link state request, link state update, and link state acknowledgement packet. They are the same, and the route calculation using Dijkstra algorithm is also the same. So these are the similarity between OSPF v2 and v3. But we also have some dissimilarity between them as well. So if we look into the difference, okay, between them, firstly, OSPF is based on link rather than the subnet. That's true. Okay, so we enable OSPF v3 on the link. Now OSPF v3 does not depend on the IP addresses, alright, because they do have a different topology for OSPF as well as the IP address prefixes. The OSPF v3 packet and the LSA format do have some changes as well. So for detail, you can refer back into the RFC. Information about the flooding scope. We do have a different type of a scope in OSPF for the LSA. We can have a multiple process on the link. Compared to previously, we can enable one link using one process, but now we can have multiple instances on the same link. And OSPF v3 uses the link local, which is FE80. Now it doesn't support the authentication natively, but they do depend on the IPv6 authentication. Alright, that will make the OSPF v3 less complex. OSPF v3 support additional 2 more LSA, and OSPF identify the neighbor based on router ID. And the router ID is 32-bit, just like our IPv4. Now, we do have many of the differences, but for your exam, I will highly recommend that you refer back into the RFC standard, okay, for more detail. But for this syllabus, I will just touch on the basic of the OSPF. And let's just look into some of the lab now. Okay, so firstly, I'm going to undo my RIP-ng early on. Okay, so I'm going to configure the OSPF. Alright, so you can see that there's a OSPF v3 with a process ID number 1. So very important is that we have to configure our router ID. Okay, let's say that this one is 1.1.1, that is a 32-bit, that is mandatory. Without this, your OSPF v3 will not work. Next, we have to go into the interface. Then we just simply type OSPF v3 process ID number 1 and what area we want to. So assuming that I'm going to use the area 0. That's it. So assuming that I'm going to use on the area 0 for the 000, so which means that 1 and 3 I'm going to use area 0, 1 and 2 I'm going to use area 1. So I go to gig 001 OSPF v3 process ID number 1 area 1. Okay, that's it. So when I do a display OSPF v3 interface, you can see that I have the interfaces already enabled. That is on your gig 001, and I also have it on the gig 000. Okay, so let me go into router 2 now. So again, I'm going to undo my RIP ng and enable my OSPF v3 router ID and my interface. Area 1. Alright, so after a while we should be able to see that the OSPF should be here. So when we do a display OSPF v3, and we are going to look into the process ID number 1 with a peer. Okay, so you can see that now we have a full with the DR. Now I'm going to do on the R3 as well, and I still have my Wireshark still running. Okay, that's great. So OSPF, undo RIP ng first. Then I'm going to enable the OSPF router ID, interface, OSPF v3 process ID area 0. Okay, that's it. So when I look into my display OSPF v3 process ID 1, and I would like to see my topology. Okay, so this will be my topology. Alright, and I want to see my OSPF routing table. Okay, so OSPF 1, I want to see my routing table. Okay, so here I have my routing table, which is the 2.0.0.1.1.12. This is the inter area, and you also can see that I have the Wireshark that's running. There you have it. Okay, so let me clear it, and I'm going to look for the OSPF v3. I think that's it. It's okay, OSPF. Alright, so that is my OSPF, that is my v3. Okay, OSPF v3, and as you can see from here, if you look into the OSPF, this is my header. You can see that the header is purely using the router ID. They do not have any IP address inside there. Okay, so that is one of the difference between the OSPF version 2 and the version 3. And you also will notice that if I just expand this, okay, so here I have my OSPF that is running, and you can see that the hello as well as the request, update, and acknowledgement. So these are very similar to what we have on the OSPF v2. And again, OSPF are using multicast. As you can see that this is a FF02. Now here we have the unicast is because on the way that v2 and v3 on forming the neighbor relationship are similar. Okay, so here I show you the basic configuration on OSPF, but definitely there are more that you can learn. You can refer back to the headaches as well as the RFC on the detailed information on the OSPF standard.
Thanks for watching. Please do not forget to subscribe to our channel.